Hi class, and welcome back to another lesson. Today we're on 2.7, which is graphing inequalities as well as graphing absolute value functions. For this video, we're going to do the front page of the notes, which is graphing inequalities. There's a couple terms that we need to cover first. The first one, when graphing inequalities, you need to switch the direction of the sign if you multiply or divide by a negative. If you multiply or divide by a negative. So I probably should have covered this before I even started with this. An equality is like y equals mx plus b. Y equals 3x plus 4. Y equals 3x plus 4. And we can graph that. This is an equal sign. So an inequality is then y is greater than 3x plus 4, or y is less than 3x plus 4. These are inequalities. And whenever this sign right here, whenever you multiply or divide by a negative, you need to switch the direction. I'm sure that you guys have been told that before. I think this is review, but maybe you've never been told why you do that. I could just explain it to you in a simple proof. Let's say we take the example 5 is greater than 4. That's correct, is it not? That is a true statement. 5 is greater than 4. Now let's say you were just to multiply both sides by the number 2. So now you would get this. 10 is greater than 8. Is that a true statement? And you say yes, 10 is indeed greater than 8. So now, let's take our example and let's multiply it by a negative 2. Now we have a negative 10 is greater than a negative 8. Is that a true statement? Hopefully you would say, no, that is not a true statement. A negative 10 is smaller, or it is less than a negative 8. So then we would have to change this greater than sign to a less than sign. So that's why this property of inequalities is true. Because if you multiply or divide by a negative, you have to switch that sign to make the statement true. Next one, shade above the line with these symbols. If it is greater than or equal to, you're going to shade above the line. Remember, only if it's in y equals mx plus b form. So if we have this one, and let's just say it's a line that looks like this, you're going to have to do some shading. This is in y equals mx plus b form, so because it's greater than, you're going to shade above the line. So I'm sure you guys can guess this one then. You're going to shade below the line with these symbols. It's going to be less than or less than and equal to. Okay? So that would be like this one right here. Y is less than 3x plus 4 if it was a line that looked like this. It's less than, and it's in y equals mx plus b form, so you're going to shade everything underneath the line. Okay? So that covers those, and make sure you always remember if it's in standard form or if it's in point slope form, you need to change it into slope intercept form, because that's how we shade. And then, to connect the dots, you're going to use a, boy, I don't know why this got off-centered here. There we are. You're going to use dotted lines to connect the points if it is greater than or less than, and you're going to use solid lines if it's greater than or equal to or less than and equal to. So if you have, like I was saying, this y is greater than 3x plus 4, you might have a line here at 4, and then it's a rise of 3, run of 1. You're going to connect these two dots, these 2 points rather, with a dotted line. If it was greater than or equal to, now it would be a solid line. Okay? So those are the notes. 1, 2, 3, 4. All of these should be relatively simple because you guys have graphed all these before. The only thing we changed was our inequality. So for our first one, 2x minus 3y is greater than or equal to 6. If you recognize this form, it's in standard form. But we always want our inequalities in y equals mx plus b form, because that'll help us do our shading. So let's change this. Let's get this y all by itself. First, we have to subtract 2x. So we have a negative 3y is greater than or equal to a negative 2x plus 6. Now that we have this, in order to get y all by itself, we have to divide by that negative 3. So if we divide by negative 3, we now have y all by itself. Remember what happens when you divide by a negative? It changes this sign. So now it is less than or equal to. A negative 2 divided by a negative 3 is a positive 2/3 x. And a positive 6 divided by a negative 3 is a negative 2. So this is the function that you are going to graph, and then you're going to shade accordingly. So it has a y-intercept of 2. Oh, sorry, a negative 2. B equals a negative 2. So you're going to go down 2 on the y-axis, put a point, and then my slope, my m, is 2/3. So you're going to rise up 2 and run 3 to the right. And there you have it. So now I ask you this question, class. Is this going to be a solid line or a dotted line to connect these 2 points? Because it's less than or equal to, you're going to use a solid line. And please use a straight edge when you connect these 2 points. And don't forget, you're not done yet with inequalities. You need to shade. So when it's greater than or equal to, you shade above the line. When it's less than or equal to, you shade below the line. This one is less than or equal to. So you're going to shade everything below the line. And you are all done. Class, I'm going to teach you how you can check your work. I'm going to do this just once, so that we won't do it on every problem to save some time. But I do want to show you how to do it just in case you want to do it on a test. What you found here is everything in green satisfies the above equation. You could pick any point in green, and it's going to make this statement true. You could also pick anything in the white here, or now I'm going to say anything in the blue, and that would make this statement false. So when you check your work on a test, just pick any point. It doesn't matter which one it is. Let's say I pick a point, and I'm going to pick this one right here. This point right here should make this statement a true statement because it's in the green. So this point is right 1, 2, 3, 4, 5, down 1, 2, 3. This point is at right 5, down 3. So this XY ordered pair should make my original statement true. If it does, I know I've done it correctly. 2x minus 3y is greater than 6. 2x minus 3y is greater than 6. Let's see if it makes this statement true. 2 multiplied by x, and I said my x is 5, minus 3 times my y, which my y is a negative 3. That's greater than 6. 2 times 5 is 10. A negative 3 times a negative 3 is a positive 9. Is greater than 6. Is 19 greater than 6? And your answer is yes, that statement is true. It checks out. 19 is greater than 6. So I know that I've done it correctly. You can pick this point. 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 There's an infinite number of points that you can pick. All of them are going to make this statement right here true. There are also an infinite number of points here, 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 here. It doesn't matter which one as long as you pick it somewhere in this region. If you substitute that x and y into here, you're going to get a false statement. So you can check these as many times as you'd like to make sure that you have the right answer. And you can do that for every problem like this. Number 2, x is greater than y. Now we like ours in y equals mx plus b form. So I always like my y on the right. Now class, if you read this from left to right, it is x is greater than y. If you read this from right to left, follow me here. If you read this from right to left, you would say y is less than x. Y is less than x. So if y is less than x, I can write it like this. Y is less than x. All I've done was basically flip-flop these two variables onto the other sides. Y is less than x. It's kind of like saying 4 is greater than 3. That's true, right? Thus meaning 3 is less than 4. That's all I've done here with this. So that's what I'm going to graph. Y is less than x, which is another way of saying y is less than 1x plus 0 if we wanted to get into our slope-intercept form. So my y-intercept is 0, and my slope is a rise of 1 and a run of 1. So you're going to connect these two dots, and what kind of a line are you going to connect them with? It is just less than, it's not less than and equal to, so you're going to connect them with a dotted line. And there you have it. Make sure you connect it with a dotted line. So your guys' graphs might look something like this, I guess. Something like that. And so now we have to shade. Are we going to shade everything above the line, or are we going to shade everything below the line? It says y is less than x. Y is less than. So that means we're going to shade everything below. And that is what I require of you on all these problems. So I'm going to look very closely on a test at your shading. I'm going to look very closely at whether you put it into y equals mx plus b form. And I'm going to look very closely at whether you use a dotted line or a shaded line to connect the 2 points. You guys try number 3. Let's do number 3 together, and then you guys try number 4 on your own. Number 3, x plus 2 is greater than or equal to 0. If you guys see this, there is no y variable. If there is no y variable, you're just going to get x all by itself. So let's subtract 2 here. X is greater than or equal to a negative 2. X is greater than or equal to a negative 2. Well, class, if you saw this, x equals a negative 2, what line comes to your head? A vertical line or a horizontal line? Hopefully you say a vertical line. So you're going to go to negative 2, put a point, and you're going to draw a vertical line. Now is your vertical line, now that it's not x equals 2, this isn't what we have. It's x is greater than or equal to a negative 2. This is our equation. So how are you going to draw this vertical line? Is it going to be a solid line, or is it going to be a dotted line? It's greater than or equal to. Because it's or equal to, it's going to be a solid line. So draw your solid line here. And now we're not going to shade above the line or below the line, obviously, because it is completely horizontal or completely vertical. So now do we shade to the right or do we shade to the left? Well, if x is everything that's greater than a negative 2, that means everything is to the right of a negative 2, such as a negative 1 and 0 and 1, 2, 3, 4, 5, so on and so forth. All of these are solutions to my equation x is greater than or equal to a negative 2. So now, you guys try number 4 on your own. Number 4 does not have an x variable, so pause the video and try number 4 on your own. So for number 4, I'm going to get my y over here by adding a y. So it's going to be a positive y plus 3 is greater than 4. And then I'm going to subtract 3 to get y all by itself. So y is greater than 1. Remember, when I added this over here, I don't have to change any signs. It's only if I multiply or divide by a negative. If I multiply or divide by a negative, that's when I need to switch the signs. So now I'm going to graph y is greater than 1. Y equals 1 is a horizontal line at 1. But I'm not graphing y equals 1. It's y is greater than 1. So I am going to have a completely horizontal line that is going to be dotted. because it's not equal to, it is greater than. And then I asked myself, how do I shade this one? Y is greater than 1, so greater means bigger, or in this case it means higher or above 1. I'm going to shade everything above the line y equals 1. If it was less than, obviously, I would shade everything below. All right, so you're going to have about 6 problems, I think, on your worksheet that deal with the inequality function. So let me know if you have any questions on those. We're going to have one more video here on this lesson about the absolute value function.